In this video, we're going to be looking at calculating displacement during acceleration, and we're going to be using the formula displacement equals VF plus VI divided by 2 times time. So first we're going to figure out where this formula comes from, and we're going to look first at a graph of velocity versus time. So our y-axis here is velocity, our x-axis is time. In a displacement, or in a velocity time graph, displacement is the area under this graph. Now, in the past, we've looked at constant velocity, and so we've just done length times width, or velocity times time. Unfortunately, now we have changing velocity, so we don't have a nice rectangle to work with. So we're going to have to figure out how to take this graph and make it more usable for us. And how we're going to do that first is we are going to find the average velocity. So the average velocity, shown here at 22.5 meters per second, so this is the average velocity that our object is traveling. This is determined by adding the initial velocity and the final velocity, and then dividing by 2, because we're looking at two different velocities. So in this case, we would have 15 meters per second plus 30 meters per second divided by 2, and that gives us 22.5 meters per second. So you'll notice there's little scissors here, and what we're going to do is we're going to cut this section of the graph. And so now, again, we're going to cut this section of the graph that's above our average velocity, shade that in red. And we're going to take that and we're going to flip it, and it's going to actually fit perfectly into this kind of blank area underneath our curve. And because it fits perfectly there, we're now able to calculate the velocity, the displacement using the area, which is length times width. But in this case, our length is going to be our average velocity, and our width is going to be the time. So we're going to write down these formulas. So again, average velocity this is going to equal our initial velocity plus our final velocity over 2. And then we know that displacement is equal to average velocity times time. And so we can rewrite this formula as displacement is equal to initial velocity plus final velocity over 2 times the change in time, or the time over which that acceleration occurs. So we're going to look at an example now. So in this example, we have a car entering a merge lane at 60 kilometers per hour east. That's our initial velocity. The car accelerates to 90 kilometers per hour east, so that is our final velocity. And this acceleration takes 6 seconds, so that is our time. So rather than draw this on a graph, we're just going to plug this into our formula. So we know that VI is equal to 60 kilometers per hour east, and VF is going to be equal to 90 kilometers per hour east, so our car is getting faster in the east direction, and our time is seconds. Now, typically we're going to use meters per second squared as our acceleration, so we're going to actually convert these into meters per second, because usually we're working with a little bit smaller of a distance. Okay, so 60 kilometers per hour, we're going to multiply that by 1,000 meters per 1 kilometer, and then divide by 3,600 seconds in 1 hour, and we get 16.7, so 16.6 repeating meters per second. We're going to do the same thing for 90, so multiply by 1,000 meters per 1 kilometer, and then divide by 3,600 seconds per 1 hour, and we get 25 meters per second. So now we're going to plug these into our formula. And so what you really need to look for before you do any of the math is that the time units here are all going to match. So you can do that either by converting the velocity or by converting the time. So now I'm going to write down my formula. Displacement is VI plus VF over 2 times the change in time. So it's going to equal 16.7 meters per second east plus 25 meters per second east divided by 2 multiplied by 6.0 seconds. And so our average velocity here, this 16.7 plus 25 divided by 2, that actually equals 20.83 meters per second east. So that's the average velocity during our acceleration. Multiply that by 6 seconds. And we get an answer of 125 meters.